Greetings from Calgary. Today I want to lay some groundwork for a series of Gadgeteer projects I hope to cover over the next number of months, involving converting various breakout boards to Gadgeteer modules. Now, why would I want to do this? Gadgeteer modules are, in my opinion, one of the biggest features of Gadgeteer. In other platforms, not only do you need to know how to code, but you also have to understand the intricacies of hardware. And this is really a lot to ask of someone just getting into building devices. Now, what if you only had to understand code and the details of how to use the electronic components was neatly wrapped up in a very nice abstraction layer, where, for example, for a temperature sensor, you could simply ask for the temperature and not have to know SPI or I2C and registry and bit mask settings required to command the chip to give you a temperature reading. That would enable existing coders to easily move into building devices and learn the intricacies of hardware as their interests and needs so motivate them. This is exactly what you get with Gadgeteer modules. Modules consist of some hardware and a software driver which contains all the interface and hardware-specific code neatly abstracted so you can code with events, methods, and properties that make sense. And not only are modules very appealing for Gadgeteer, but now you can use GHI's electronic Fez Cream to connect Gadgeteer modules to a Raspberry Pi running Windows 10 for IoT. I also believe the Gadgeteer modules make it easy for hardware developers from large companies to hobbyists to create very appealing hardware devices for others. For example, I have purchased a large number of Gadgeteer modules from hobbyists, and sales of their modules have helped them to make their hobby self-sustaining or even grow into a business. So in this video, I'm going to show you the tools and an overview of how to build a software driver for a Gadgeteer module. First thing to cover is Gadgeteer Sockets, as those determine the interface to the module. Gadgeteer Sockets have 10 pins. Pin 1 is always 3.3 volts, Pin 2 is 5 volts, and Pin 10 is a ground. That leaves 7 pins for data interface, controls, etc. For example, for an S socket, which is SPI, Serial Peripheral Interface, Pin 7 is the master out, slave in line, Pin 8 is the master in, slave out line, and Pin 9 is the clock. In addition, Pins 3, 4, and 5 are general purpose input-outputs, with Pin 3 supporting interrupt capabilities. An I socket is for an I2C interface. Pins 8 and 9 are the dedicated I2C data, SDA, and clock, SCL lines. In addition, Pin 3 and 6 are general purpose input-outputs, with Pin 3 supporting interrupt capabilities. So, these are just some examples of the different interfaces that Gadgeteer sockets support. They have a very rich list, as we can see here, of different interfaces that they can handle. So now we know how our module connects to the main board, and we'll assume that we've built the hardware for the module. So what do we need to create the driver? First, we need the Gadgeteer builder templates, which are free and available on Codeplex Gadgeteer site. Note, I'll post links to everything below. Here you'll also find documentation for module builders. Note, you do need to have Gadgeteer installed on your system as well. Next, we need the WIX toolset to build the installer. When you build a driver for a module, you get a Windows installer package. So all users have to do is run the installer and the module is installed, so it's available in the designer. Note, you can also uninstall a module driver from the Windows control panel. So you see, Gadgeteer modules are very attractive and easily packaged for developers to use. So after installing the builder templates and WIX toolset, you'll notice some new templates. So let's go through and we'll build a sample project. So we're going to say File, New Project, And now you see we have this mainboard module and Gadgeteer kit, which come from the templates, the builder templates. So we're going to build a new module. And so let's call this demo button. Okay, and so now we're going to say OK, and it's going to ask us some questions. So we've got a module name, demo button. It's going to ask us for who our manufacturer is. So we'll just say my company, and we want to give it a safe name without spaces. And what we're going to do is we're just going to build this for the .NET Micro Framework 4.3. 4.1 and 4.2 are fairly old, so you might want to just skip those. Not many people are using those anymore. So then we're going to say create module. And so now what Gadgeteer is going to, or Visual Studio is going to do, is it's going to go and build us a module project complete with sample code and everything else. So we'll go through this, and I'll show you typically the places where, as a developer, you have to put some stuff in to the code. So the first place we're going to start with is the Gadgeteer hardware XML file. And so what this contains, the two things that you typically have to change in here, is the board height and the board width. And this is the size of your module in millimeters. And then if we scroll down here a little bit, you'll see that there's some descriptions of the socket. And so in this example that they've given us, they've created 2 sockets. And so one of the things that you'll have to do is figure out where on your module your socket is located, what the orientation is, what types of sockets it is. And then if you know what your power requirements are for your module, you can put those down here and uncomment this out. So there we've kind of given a sort of an overview of our socket. The other thing then we have to do is we've got to create an image of the socket. Now usually this is just you take a photo of your module and orient it such that how you describe the socket in the XML file, so that the socket image in the designer appears over top of the image of the socket on the picture. So we'll just open up this image file. I don't have a photo or anything for this. We're just going to open this up, and we're just going to make it something so that it shows up. We'll use this. We'll get an error because there's nothing there, so we're fine with that. We'll come down here. We'll pick some funky color. We'll just drop some of this on there. Fine. File, save. And we want to save this as a JPEG. We'll just call that image. Yes, that's fine. Okay, great. Like I said, this is usually you just take a photo of this, and so you try to get your lighting and everything nice so that you can see all the details of the module. So we'll close this up. So now we can see that yes, we have an image there. So there's that. So now we've kind of just got an image of what our module looks like, and this shows up in the designer. And then we come down here, and here is where we put our code for this module. And so you see, we simply create an instance of the class. We pass it what socket we attach the module to. In this case, they've added a second socket. You can do that with Gadgeteer. I've got some modules that have 4 or 5 sockets that they connect with. They're quite elaborate, but most modules only connect to one socket. And so then we come in here, and we're going to create an interrupt. So what the code is that they give you is a very simple button. And so on pin 3, we're going to be looking for a rising falling edge, which is sort of like someone pressing down on a switch. So the edge, the line goes high, and when they release the button, the line goes low. So this is just a simple binary type line. It's either it's high or low. But when it changes, we want to get an interrupt. We want the the device to let us know that someone's pressed a button. So then we're going to create this interrupt, and we come on here, and so we're going to have on a button event, and we're going to also pass it what kind of state that this is, and this we get the state by reading the line, and if the line's high or low, we're going to return that it's either pressed or released. And then we come in and we create a button event handler. And then what we do is we check if we create this this event and we raise it, check and invoke. So we raise this event and we button press sender, which is the module that is raising the event. So you might have multiple buttons on there, and you might want to know exactly which button it was that sent this. And we're going to pass the button state, which is either pressed or released. Alright, so we have this button released, button pressed. So we have two events that we're going to have. And that's all there is. I mean, it's really actually quite simple. But like I said, for somebody who is just getting into building electronic devices, they might not know how to read schematics and know which pins are doing what, or how the chips work or whatever. And so as a hardware builder, when you create these drivers for the modules, it isolates off everything for them. So one of the things that I like to do when I build a driver for a chip is I like to create a sample app or a test app. So we're going to say add new project, and we usually give this, so this is going to be a Gadgeteer application, and we're going to call this test app. And whatever, we'll charge, we'll grab a spider board, and we'll create this. So now what we're going to do is we're going to take an instance of our button and we're going to put it on this board, and we're going to write some code around that. So if we come in here, we can say, come in here, let's add the reference here. So we're going to say add a reference, projects, we're going to of course grab the latest one. And then we can come in here and we can say private demo board, and we're going to call this demo button. Equals new. Now remember it had two sockets, so we're going to say 10 and 11 just for the sake of that. So then what we can do is we can see in here that we'll have our demo button, and we've got the events that we've coded for in our driver. So we'll say button pressed. Oh. And that creates an event handler for that. Demo button, and released. And then we can come down here and we can say something like debug.print button released, and we can do the same thing down here. And so we can see how easy this is for us to use the modules that we created, the software for it, because we don't have to know what pins or how the interrupts or whatever work. We're just working with the events that we want to handle. And so that would be a sample program that we could use. Now, we've got everything coded up. So now how do we go about building this driver? So one of the things I always like to do, so I do a build solution, make sure I don't have any bugs in my code. But when we do a release build, Gadgeteer is going to go through and it's going to use WIX, and it's going to build an installer. So let's have a look at that installer. Should have brought this over. So here's our demo button project. So we can see there's our test app project that we built. And we come in the demo button. Here's the different versions. We built ours with only 4.3, but if we go into here and we go into bin, and to release, there's an installer. And so now if somebody is to run this demo button installer, it will place our module in the designer. So when they go through and build their project, they can use our, and we'll do this in a second. And they can also use the Windows control panel to uninstall too. So let's save this, and then we'll just close the solution. Actually, let's close this right up. And then let's run our installer. And so now it's going to install it on our system. Yep, looks good. So we'll fire this up, and what we'll do is we'll create a Gadgeteer project, and then we'll see that this our new module has been added to the designer and stuff. So we'll let this fire up. My poor old machine is just getting thrashed here with all the things that I do with it. And we'll minimize that. Oh, sorry. Okay, so now if we go in here and we say File, New Project, and we're just going to make this a Gadgeteer application. I don't really care what it names it. We're just going to throw this away. We'll pick, if you can see, there's lots of different main boards for Gadgeteer and .NET Microframework. So we'll just grab a Reaper here, and it's going to create our application for us. And then we're going to go into the toolkit and the designer, and we're going to see if our new module has appeared and what it looks like when we drag it on the designer. So it's going through and creating this project for us. And there we go. So we come into the designer. So there's our main board, and again, this is why we the pictures are important, because this is how it's going to show up in the designer. So if we come in here, and I think we called this demo button, my company demo button. So if we drag this over, so you can see it's the green color that we gave it. Here's the two sockets that were put on there from the XML file. So if we click on it, it'll show us all the sockets we can connect to. And so that would be, and then let's just for fun, we'll just pick a real button so you can see what it would look like if we actually had a nice image and cleaned it up and stuff. And so there's our module in the designer. So then if we go into the code, we can come in here and we can say demo button, and we can use our event handlers and such. And so again, a very nice way to build hardware, package up the software, that's specific to the hardware in a nice little driver, and then distribute it that way. And so I think this is, again, I think this is one of the nicest features of Gadgeteer, is how the hardware details are abstracted away, so software developers can start building devices right away without having to know the details of the hardware. Now, if you're a hardware developer and you want to see some examples of how drivers are written by different companies, there's lots of open source drivers. So like here's the button for the other button that we use from GHI, so you can see how they've got their stuff set up. So they have just a single socket. It's an X or a Y socket. You can see though they also have an LED button, LED on their buttons that you can use for toggling it on and off, and all the details around that are all hidden away. So there's tons of different drivers you can see how people have written, or you can go. GHI has moved their latest releases of their modules over here to Bitbucket. So there's lots of examples of how to write drivers for the hardware. And then let's say you go and you build a a module and you'd like to put it somewhere where Gadgeteer folks can see it and possibly buy it. So for example, this simple temperature module, I bought a couple of these, $4.57, and he shipped them to me. They were a great little module. I was really glad I got those. Same with the HAL, these Hall modules and such, the temperatures and everything, the bolt. So this is it's a great place so that you can let Gadgeteer developers know about this. This is the GHI Electronics community site. So a lot of .NET Micro Framework guys, Raspberry Pi guys for Windows 10 IoT, and Gadgeteer people hang out here. And so, we've bought. You can advertise your modules here for free. Like the beam breakers RF pipe is a really cool module that I've got from Justin. Justin kind of got his start in hardware building different modules, and has now gone on to he's building some really cool hardware now. So again, I hope this has given you a bit of an introduction into how easy it is to build software drivers for Gadgeteer modules, and how nicely it packages them up so that hardware guys can distribute their hardware very easily, and software guys can feel fairly safe downloading it and installing it. If they don't like it, they can always uninstall it. It's not a problem. It's a Windows, like I said, it's a regular Windows install process. And so, like I said, it just makes Gadgeteer modules just a beautiful thing to use. So again, I'll post links for everything that I've mentioned in this talk below. And then hopefully here in the next couple weeks, months, you're going to start seeing me posting things like the first project I think I'll put up is I did a driver for a SparkFun sound detector board, and so I've converted that so that it's just as easy to use as the Gadgeteer module. You just pull it off the designer, and then you can use the events and stuff that I've created. I've got lightning detectors and all sorts of different breakout boards that I've converted to Gadgeteer modules, and so I'll start putting those up. So until next time, happy Gadgeteering.